Question is, in the reaction 4A plus 2B plus 3C gives rise to A4B2C3. We have to find the number of moles of products formed will be. So the given reaction is 4A plus 2B plus 3C, which gives rise to A4, B2 and C3. So here in A it contains 4 moles, in B it contains 2 moles, and in C it contains 3 moles. Here if 4 moles need 2 moles of B, then what will 1 mole of A needs how many moles of B? So by calculating it, 1 into 2 by 4, that is 1 by 2 moles of B is required for 1 mole of A. Whereas given B is 0.6 mole. As compared, it is excess. So we have to leave B. Then when we come to the next part, it is if 4 moles of A need 3 moles of C, then what if 1 mole of A needs how many C? By calculating it, 1 by 3 and by 4 gives you 3 by 4, that is 0.75 mole, right? Then in the question given moles are 0.72 moles of C is given. So the limiting reactant is C. So 3 mole C gives 1 mole of A4, B2 and C3. So how is if 0.72 mole of C is where how much mole of A4, B2, C3 is obtained? By calculating 0.72 into 1 by 3 gives you 0.24 mole, and the answer is 0.24 mole. Question is, when sample of baking soda is strongly ignited in crucible, it suffered loss in weight of 3.1 grams. The mass of baking soda is. According to the question, let's write the equation. NaHCO3 is the formula for baking soda. So on heat, we get the equation as Na2CO3 plus H2O plus CO. By balancing the equation, we get 2 NaHCO3. So here, if we observe, these both are in gaseous state. So there will be a loss of these molecules because they are gases. They are gases. So how much? What is the molar mass of H2O? It is say 18 grams. Whereas in CO, it is 44. So the loss of these two gases in grams is 62 grams of loss. So here the molar mass of NaHCO3 is 84 grams, multiply by 2. Yeah. So here the here you have given us suffered loss in weight of 3.1 gram of the mass of baking soda. So this is 3.1 and here you get 6. Just a second. So they said here it is 62 grams, here we have loss, and then they said it is 3.1. uh, in the question. It suffered loss in weight. So what will be the mass of baking soda? So after doing by multiplying these both and dividing by this, that is 2 into 84 into 3.1 by 62. If we divide it, 2 ones are 31, 0. Here we get the answer as 8.4 grams. So the mass of baking soda is 8.4 grams. Answer. The third question. 0.2 moles of a hydrocarbon which cannot decolorize bromine water on complete combustion produced 26.4 grams of CO2. Then what is the molecular weight of the hydrocarbon? So let's write the equation like this. Let the equation is CXHY. Because it is hydrocarbon, it contains only carbon and hydrogen, plus O2, because here they are telling about combustion. We have to add oxygen, which gives rise to CO2 plus H2O. Right? Here they have already given, that is 0.2 moles of hydrocarbon. As we are taking the hydrocarbon as CXHY, it contains 0.2 mole. Right? And here the given is 26.4 grams, 26.4 grams, and for 0.2 mole we are getting 26.4 gram. Then what about 1 mole? If the hydrocarbon has 1 mole, what is the weight of CO2? So here comes the answer, that is 1 into 26.4 by 1. That is nothing but 0.2. Just a second. 0.2, and the answer is, by dividing it we get 132 grams in, so 132 grams is the mass of CO2 if the hydrocarbon is containing 1 mole. Okay, so in the given options, as the options are A 44, B 42, C 40, and D 58. Let's compare them. So verifying first option, it is 132 by 44. If we divide it, we get the answer 3 moles of CO2. So your equation will become, if this is the case for the first option, we get the equation as C3H plus O2 gives rise to 3CO2 plus H2. So the correct option is 44. The question 4. The sulfur dioxide obtained by the combustion of 8 grams of sulfur is passed into bromine water. The solution is then treated with barium chloride. Then, what is the amount of barium sulfate formed is? So let's write the equation. First they said sulfur dioxide is obtained by the combustion. Okay. So S, the combustion, it formed SO2, that is sulfur dioxide. And from here it has passed into bromine water and it formed BaSO4, that is barium sulfate. So here in the question they have given that 32 grams of sulfur is required for 1 mole of BaSO4. Then if there are 8 grams of sulfur, how many moles are required? I repeat it. here from sulfur, the combustion of with combustion of sulfur, that is S plus O2, which gives us O2. We got SO2 over here. That is, with combustion of sulfur, we formed sulfur dioxide. And when the sulfur dioxide is passed into bromium water, the solution obtained is BaSO2, which is also known as barium sulfate, right? And the molar mass of SO2 is 32 grams. For 32 grams, 1 mole of BaSO4. Here we observe 1 mole of BaSO4 is formed. So in the question, if there are 8 grams of sulfur, if 8 grams of sulfur is passed in bromine water, how many moles or how much amount of barium sulfite is formed? Let's find it out. 8 into 1 by 32, that is 1s are and 4s are, which gives you 1 by 4, that is 0.25, right? So the amount of barium sulfate formed by it is 0.25 gram moles. So the required answer is 0.5 grams. Alright. Fifth question. 1 mole of a mixture of CO and CO2 requires exactly 20 grams of NaOH to convert all the CO2 into N2CO3. How many more grams of NaOH would it require for conversion into Na2CO3 if the mixture is completely oxidized to CO3? From the question, two compounds, we have to get a clarity on these both, that is CO and CO2. CO and CO2. What type of oxides are this? Just guess. What types of oxides are this? Okay. So CO is a neutral oxide. What type of oxide is CO? It is neutral oxide. But whereas in the case of CO2, it is an acidic oxide. Now, with this hint, we can understand which is reacting with NaOH and which won't react with NaOH. So, CO as it is a neutral oxide, it doesn't reacts with NaOH, right? Very easy to understand. But whereas in CO2, acidic oxide, as it is an acidic oxide, it do reacts with NaOH, right? So now we have understood that CO won't react with NaOH and only CO2 will be reacting with NaOH. So let's write the equation for that. That is NaOH plus CO2, which gives rise to Na2CO3 plus H2O. So this equation or this reaction is not yet balanced. To balance, I'm just adding 2 NaOH. So now the reaction is balanced. So from this, we can understand that it contains, NaOH contains 2 moles, right? Whereas CO contains, that is carbon dioxide contains only 1 mole. In the question, they asked how many more grams of NaOH is required for conversion of CO2 into N2CO3. Okay, here let's write it. What is the molar mass of NaOH? It is 40 grams, right? So 2 into 40, that is 80 grams. That means 80 grams of NaOH is required for 1 mole of CO2 to form Na2CO3. So here comes the answer. That is, we need 80 grams of NaOH. We need 80 grams of NaOH so that CO2 will be completely oxidized and it gets formed into Na2CO3. So the required answer is 80 grams of NaOH. So this is the answer for this question. Thank you.